Okay, so we're going to start with our main idea for the unit, which was the atom. One of the things that we've talked about this unit with regards to the atom was its structure. What is the atom made out of? And we discovered that there are two main parts to the atom. There is the nucleus, and inside the nucleus we have protons and we have neutrons. And then the other part of the atom is the electron cloud. Or as Schrödinger referred to it as the orbitals. And the electron cloud contains, hey, guess what? The electrons. Then we talked about how we could find specific things that would tell us how many protons, neutrons, and electrons are in my atom. And we said that the atomic number was going to be equal to our electrons and our protons. We also said that if we added the protons plus the neutrons, we would get our mass number. And then mass number minus atomic number would take us back to our neutrons. We spend a good chunk of time this unit talking a little bit about the history of the atom, which is important in understanding sort of how we know what we know. Okay? So the first historically important scientist, not really a scientist, he was more of a thinker, was Democritus. And remember, he came up with his thought model, his idea that the atom was the smallest piece of matter. You could divide and divide and divide and divide and divide, but eventually you would reach something indivisible called the atom. Okay? 2,000 years later, remember, Democritus was discredited by Aristotle. So 2,000 years later, a guy named John Dalton came along, and he agreed with Democritus's idea that the smallest particle of matter was the atom, and he came up with his atomic theory. The difference being he had evidence. He had scientific evidence to back his idea up. And so he was able to come up with an atomic theory. And from his atomic theory, we sort of created what is referred to as the billiard ball model of the atom. His was just that circle. So his was just a circle. Okay, well, a sphere really. Okay? He said 4 major things. He said the atom was the smallest particle, it was indivisible, and all matter is made of atoms. He said that atoms of the same element would be identical. He said that atoms combine in whole number ratios to form compounds. And he said that a chemical reaction is when atoms separate, rearrange, and recombine and bond to form new substances. Most of which was true. But then J.J. Thomson came along, and he actually disproved part of Dalton's theory because he discovered the electron. So Thomson came along and discovered the electron. So we're going to connect Thomson to the electron. So Thomson was credited as discovering the electron. So he disproved Dalton's theory in the sense that the atom was the smallest particle because the electron was 10,000 times smaller. So Thomson took that billiard ball model and he modified it into the plum pudding model. He said that yes, you've got a sphere, there's your atom, but within the sphere itself is positively charged, but you have these little chunks of negative charged electrons within your positive charged sphere. Okay? So then Rutherford came along with his gold foil experiment. Okay? And he discovered that no, this doesn't really work, because if this was true, when he did his gold foil experiment, all of his alpha particles would have just gone straight through, which is what happened most of the time, but not all of the time. Some of the time, things were bouncing back at him. So he created what is referred to as the first nuclear model of the atom. He put the positively charged protons in the center, and then he said the negatively charged particles were in the outside. Well, after Rutherford, we had Niels Bohr. Oops, we forgot to connect Rutherford to the nucleus. So Rutherford, he goes to the nucleus. So Rutherford discovered the nucleus. After Rutherford, Bohr comes along, and he's looking more specifically at the electrons. He's saying, hey, wait just a minute. I don't think they're just out there in this empty space. I think there's a little bit more rhyme and reason to it. And he was looking at energy levels created by the electrons based on the wavelengths of light that they released. And so he came up with what we call the planetary model. He said that the electrons would orbit the nucleus in a manner very similar to the way that planets orbit the sun. So we still have that positively charged nucleus in the center, but now we have energy levels that are going to have electrons in them. Okay, so that's the planetary model. The most current model of the atom was created by several scientists, but mostly Schrödinger came up with what we refer to as the most common model of the atom. He came up with the wave equation model. Oops, there's a U in there. The wave equation model. So we have our nucleus in the center, and then he was able to sort of plot the places that the electron had been and able to graph them into a sort of a scatter plot of the probable location where the electron was most likely to be found. So those are the historical models that led to our current understanding of the atom. Then we talked a little bit about, Schrödinger. We have to connect him to our structure as well. Schrödinger was responsible for the discovery of the electron cloud and the orbitals that are in it. So then we talked about, specifically related to atoms, this idea of isotopes. Okay? We said there were two ways to write isotopes. We could do hyphen notation. And remember, with hyphen notation, we write the name of the element. We draw a hyphen, and then we do its mass number afterwards. Okay? So name hyphen mass number, that's hyphen notation. Then we have the nuclear symbol notation. With this one, we're going to take the symbol and we put mass number over atomic number over on the left-hand side. So symbol with mass number over atomic number. Okay? When we looked at isotopes, we talked about how we had to use their relative abundances to determine their average atomic mass. So we did step 1 was to move the decimal. Then we multiplied. And then we added. Okay, so we did that with our relative abundance, and that got us the average atomic mass. And remember, the average atomic mass is when we have the units in AMU. Then we talked about what's an appropriate sample size for calculating this average atomic mass. We talked about using the mole for that, and that when we use our average atomic mass to measure grams, we no longer call it the average atomic mass, we call it the molar mass. And the unit for that is grams. So in a nutshell, that is our vocabulary for the unit. I hope that's helpful to you.